Hi everyone, today's video is about again Burp Suite, but this time after doing the proxy, target, scoping, repeater, and intruder, we're gonna see the other three modules that we'll talk about today are there's more than just repeater, proxy, and intruder. There's also decoder that can be used to encode text and decode it. Then there's comparer, which compares sets of text. And finally, there's sequencer, which analyzes randomness of captured tokens. So, what is decoder? The decoder module allows us to manipulate data. It can be used to decode information that we have captured or also encode data to be able to send it back to the target. But it can also create hash sums of data, and as well as it provides a smart decode feature, which will attempt to decode provided data recursively. If you do use CyberChef, it's like the magic function in CyberChef. So if you look at the decoder tab, what we'll find here is first a box where we would paste and type text to be encoded or decoded. And like the other modules that we've seen before, we can send data here from other sections of the framework just by right-clicking and choosing Send to Decoder. Then there's the option that we can select between treating it as text or treating the input as hexadecimal. And then we have this drop-down menu to say is decode as or encode as or hash the input. And finally, the smart decode, which attempts to decode the input automatically. So as we put the word data into the input, it will replicate itself in the output. So when we click on encode as URL, it will end up looking like this. So let's take a closer look at the manual encoding and decoding options there are. So when we click on encode as, this is all the menu that we get. So there is plain, which is plain text, is text before performing any transformation. Then URL encoding, which is used to make data safe to transfer in the URL of a web request, and it changes characters for the ASCII character code in hexadecimal preceded by a percentage symbol. So, for example, the slash in ASCII is 47, which means in hexadecimal it is the number 2F. So it transforms the slash into percentage 2F. And this type of encoding is really useful for any kind of web application testing. Then there's the HTML, which encodes text as HTML entities, which involves replacing special characters with an ampersand followed by either a hexadecimal or a reference to the character being escaped, then a semicolon. For example, the quote would be ampersand QUOT and then semicolon. So the double quotation mark is replaced by this. So this encoding method allows special characters in the HTML language to be rendered safely in HTML pages, and it has the bonus of being used to prevent attacks such as XSS. So when we use the HTML option in Decoder, we can encode any character as its HTML escaped format or decode captured HTML entities. Then there's the base64. This is also a widely used encoding method that encodes any data in an ASCII compatible format, and it is designed to take binary data and encode it in a format suitable to transfer over any medium. Then there's the ASCII hex. So this option converts data between ASCII representation and hexadecimal representation. So for example, the word ASCII in hexadecimal number is 41 for the uppercase A, 53 for the uppercase S, 43 for the uppercase C, 49 for the uppercase I. And that is because the character A code in ASCII is 65 in decimal, which means it is 41 in hexadecimal. Then there is hex, octal, and binary. These encoding methods all apply only to numeric inputs, and it will convert decimal to hexadecimal, octal, or binary, and vice versa. And if you don't know what octal means base 8. So decimal is base 10, hexadecimal is base 16, and binary is base 2. Then the last one is gzip. So this compresses data to reduce size of files and pages before sending them, and it encodes and decodes gzip data. This is a widely used compression method to reduce size files, because we know that smaller pages mean faster loading time, which is highly desirable for developers looking to increase their SEO score, and it avoids annoying their customers. Anyway, Decoder allows us to manually encode and decode gzip data, although this can be hard to process as it is often not valid ASCII or Unicode. For example, that's the text and the compressed with gzip. On top of all of these that we've just seen, we can also layer multiple encoding or decoding functions. So for example, let's do this Burp Suite decoder, and let's convert it to ASCII hex. Then from this we can encode it again to octal, for example, and so on and so forth. So when combined, these methods gives us a great deal of control over the data that we are encoding and decoding. So, and as you can see here, every encoding and decoding method is color coded. When it's plain text, we get it in black, as here. Now, if we encode it into ASCII hex, this one turns green, because ASCII hex is green. Then the output is now the plain text for the next encoding or decoding method. So if we click on octal, this one turns light blue or cyan, and the result turns black because it's the next plain text for the next encoding or decoding method. And if we wanted to have a URL encoding, this one turns red, and this is the result. And so it allows us to quickly and easily see what transformation has been applied, and so on and so forth. We can also see the hexadecimal format for it. So if we click on hex, here we'll be looking at the same thing but written in hexadecimal. So this is the B, this is the U, and so on and so forth. And we have the ASCII just next to it. And this settings allows us to view and edit our text in hexadecimal byte format, which is a very useful thing if we are working with binary files or non-ASCII data. Then there's the smart decode. Let's get this piece of data. So from this piece of data, what we can do is using the smart decode to have an answer. So if we don't know what was the method that was used to encode the data, we can just use smart decode. So this is very useful for quickly decoding unknown data, but it's far from perfect. You won't always have an answer. So now let's just do the practice. It says, let's start simple and encode it in base 64. So once this is encoded, it's base 64. It also asks us to use URL decode to decode some data. So now we have this data and it asks us to decode it with URL. So we can use this and we have the answer. So next we have this piece of data and it asks us to decode it. We don't know what it is, so we're just using smart decode and we end up with this number. So it went from, if we go back here, it went from HTML. Then once it was decoded into HTML, we got a URL. So it was encoded using URL encoding, and that's how we end up with the number. And for the last question, asking us to encode this using first base 64, then after the base 64 converting in using ASCII hexadecimal, and then finally encoding this one in octal. So as you can see, we can do many layers of encoding as we want, or decoding, or anything. In addition to encoding and decoding data, it can also gives us the option to generate hash sums for our entered data. So before we go into more details into how to use the hashing part of it, let's look at what is hashing. So hashing is a one-way process that is used to transform data into a unique signature, or a hash, or a digest. So for example, if we had these three words, these three different strings, one is about, plain text, and something, and we want to hash each one of them, we'll use a hash function and we'll end up with these results. And because we said it's a one-way process, which means we can go back from the hashes or digest to the plain text that we came from. So a good hashing algorithm will have, as a result, a unique hash for every piece of data entered. So for example, if we take this word MD5 sum and we generate the hash using the MD5 algorithm, we'll end up with this hash. But if we have this one, so here sum is completely in uppercase, and we generate its MD5 hash, we'll end up with this hash, which is different from the first one. And that is because we just changed from lowercase sum to uppercase sum. And that's why hashing is used to verify files and documents' integrity, as even a very small change to the file will result in the hash sum changing significantly. So before continuing, I have to talk about this point, which is hash collision. So what is hash collision? A hash collision is just like having two or more pieces of data that are different that hashes to the same result, to the same hash. For example, in this you have John Smith and Sandra D that hashes both to O2. So this is because of the pigeonhole problem. So if you don't know what the pigeonhole problem is, it's the fact that if you have, for example, 4 pigeonhole and you have more than 4 pigeons, if you have like 5 pigeons, you'll have at least one pigeonhole that will be having more than one pigeon. And in hashes, because the amount of data that is in the input is tremendously bigger than the possibilities that exist for the hash results, if we take, for example, MD5, the MD5 algorithm will take into input data of any size, but will render every time a hash or digest, which is 128 bits. So a good hash algorithm should have a probability of hash collision occurring as low as possible, and this is why MD5 algorithm is deprecated. So why do we use hashing? There's many reasons, one of them being also used to securely store passwords. We talked about the integrity of files and documents, but we also use them to store passwords because there's no way to reverse that function. So it means that we can go from the hash to its plain text. So the password will be relatively secure even if the database was leaked. So when a user creates a password, it will firstly hash the password in the application, then send the hashed password to the server, which will be storing the hashed password in its database. Then, when the user wants to log in, it will be sending the hashed password, and the server will check with the stored hash, and if the hashes match, then the passwords was correct and the client can access to its account. So by using this methodology, no password is ever stored in the servers. It's just the hash of the password. So let's do some practice with the hashing part. So the first question is, using decoder, what is the SHA 256 hash sum of the phrase let's get hashing? So we'll do as before and use hash. As you can see here, there's many hash algorithms possible. We want the SHA 256, and here we have it. But it's asking us after that to convert it into an ASCII hex for the answer to the question. So moreover, we'll go here and use ASCII hex, and here we get the answer. Now, after this, the next question is generate MD4 hash sum for the phrase insecure algorithms. So still with the hash, but this time we need MD4. Here's the MD4. And then to encode it using base 64. And here we go. Okay, now that the next question is, let's look at an in-context example. First, download the file attached to this task. So we go to this file. So I'm just gonna download the task file. And the problem is, some joker has messed with my SSH key. There are 4 keys in the directory and I have no idea which is the real one. The MD5 hash sum for my key is 3166 and so on and so forth. Could you find it for me? So let's open the first key, copy in the whole thing, paste in it. Here we're using not uncode but hash MD5, and we can encode it using ASCII hex. And no, it's not the right key, as this one starts with B5. Let's open the second key, copy in it all, paste in it, and still not the right one. Let's open the third key, paste in it, and encode in it, and yep, that's the one. Now that we're done with Decoder, the next module that we'll see is Comparer. And as the name suggests it compares 2 pieces of data, whether it's by ASCII words or by bytes. So if you take a look at the interface, we have this panel, which is where the we have the items being compared. And so when we load data into Comparer, it will appear as rows in these tables. And we then select two datasets to compare. Then this part is the options for pasting data, loading data from a file, removing data, so the current row that we want to remove, and clearing all the data set. And the last part that is on the bottom is where we have the options to compare our data sets by either words or bytes. And like most modules that we've seen until now, we can just send the data from other modules to Comparer using right-clicking and choosing Send to Comparer. So when we have loaded the data into Comparer, we get a pop-up window showing us the comparison. So if you see here, this is the compared data, and it takes up most of the window. It can be viewed in text or hex format. As you can see on top, you have text or hex. There's also the length of both. So the one on the left is 306 and the one on the right has a length of 305. Then there's the key. So the key comparisons here shows us which colors denote modified, deleted, or added data between the two data sets. So on the left you have on space the, which is highlighted, while the one that is highlighted on the right is on no space the. So on the white C, but with no space between the on and the. And then there is the sync view checkbox. And when this is selected, this means that both sets of data will sync formats. So if we change to one of them to hex, the other will do the same to match, and vice versa. So why do we use Comparer? It's to quickly compare two pieces of data. It's quicker to use it than to look at it with your eyes only, and it's nice to have, like in credential stuffing or in brute forcing, to compare two different responses or two responses with different lengths to see where's the difference. So instead of like trying to find the difference between two responses, we can just send them to Comparer and it will highlight us what is different. Let's do an example. And for that, we're going to navigate to the support login page of the website that we've seen in the previous videos. So it's support login. And before logging in, let's turn in the proxy. And on Burp Suite, let's turn on the intercept, and I'm just gonna add the scope, and also in the proxy say and URL is in target scope. So now that this is done, what I'm going to do is log in with anything that doesn't work with an invalid username and password, send in this to repeater. Once this is sent to repeater, I can send here to have the response, then send in the response to Comparer. Now I'm changing the username and password. So by the way, if you want to know more about repeater, you can go watch the video about it. It will be linked down below in the description box. We're gonna use a valid username and password. Send in it. and send in this one too to compare. Now that both of them have been sent to compare, we have these two items. We can compare them by words. And here's the difference. We see that the time is dependent on when we sent the request, so it doesn't matter. However, the content length is different. Here it's 224, this one is 236. And in this one, you have the location, so location goes to login, while here it was deleted, so it's not here. And same here, you have support login and support login, when here there isn't. So as you can see, we have a direct view of what has been changed, what has been modified, whether it has been added or deleted. And if I want to, I can change it directly into hexadecimal. And if I'm putting sync views and I change one into text, the other also changed into text directly. And you can see the lengths of both. So this one is 674 bytes, while this one is 593. So we've seen decoder, compare, and now we'll be talking about sequencer. It's the last one we'll talk about in this video. So sequencer is a tool that is generally used in web app pen testing and not in CTF, like you wouldn't use it for CTF, as it is used to test the randomness of any tokens that should be unpredictable. Randomness are also called the entropy, but let's not go into detail of what entropy means. Just remember randomness. So what are the tokens that should be unpredictable? We have the session tokens, the anti-cross-site request forgery tokens, password reset tokens, and so on and so forth. So tokens, I've been talking about tokens since earlier. What are they? They are strings used to identify something, and it should be generated in a cryptographically secure manner. In other words, they are strings that should be random. So we mostly use this for pen testing to verify that they are random and that an attacker wouldn't be able to guess a token. So let's take a look at the interface. This is the interface. We get to, the first thing we see is the live capture subtab. So the live capture is the default subtab for sequencer, the one that's open when we open sequencer. And it allows us to pass a request to sequencer, which we know will create a token for us to analyze. So for example, we may wish to pass a post request to a login endpoint into sequencer and verify the randomness of the cookie that is given to us by the server. And so with the request passed in, we can tell sequencer to start a live capture, and it will then make the same request thousands of times automatically. And it will store the generated token samples to analyze them. And once the number of tokens that has been accumulated is enough, we can stop sequencer and allow it to analyze the captured tokens. While the manual load allows us to load a list of pre-generated token samples straight into sequencer for analysis. So by using this one, we don't have to make thousands of requests to our target, which is really loud and resource intensive. But it does mean that we need to obtain a large list of pre-generated tokens. Let's try and do a live capture and analysis. Now we are here. First, let's go to admin login. So that's the thing that we get. We send this to sequencer, And once we are in sequencer, there is, as you can see, in the token location within response, you have cookie and you have form field. The one that we want to analyze is login token, which is sent to the form field. And then we can start live capture. But before that, because I want you to see how noisy it is, I'm opening Wireshark and making it listen to the communications and start live capture. So we just started the live capture and we already have like 2,000 packets, more than like 3,000, and so on and so forth. And we need, and I'm gonna wait for capturing around 10,000 tokens before stopping the live capture and analyzing the tokens that have been captured.
A few moments later.
So we are at the 10,000. Let's pause. I'm pausing this instead of stopping just to be sure, like if when we analyze it, let's analyze now. When we click on the analyze now, sometimes if you don't have enough tokens, instead of, if you had stopped, you wouldn't be able to resume, but by pausing, you can just resume. So here it says, in the analyze section here, what we have at the end is 4 things: the summary, the character level analysis, the bit level analysis, and the analysis options. So we are just gonna have a look at the summary. But before that, remember I launched Wireshark when just before launching the attack by sequencer. And here are the numbers of packets that have been sent and received. That's a whole lot of packet over here in a few minutes. So let's go back to the analysis. So here, what we can see, it says overall results. The overall quality of randomness within the sample is estimated to be excellent. At a significance level of 1%, the amount of effective entropy is estimated to be 101 bits. And so this is at the 1%. Here's what we have, 101 bits. That's what we found. And then it says the chart shows the number of bits of effective entropy at each significance level based on all tests. And each significance level defines a minimum probability of the observed results occurring if the sample is randomly generated. When the probability of the observed result occurring falls below this level, the hypothesis that the sample is randomly generated is rejected. Using a lower significance level means that stronger evidence is required to reject the hypothesis that the sample is random, and so increases the chance that non-random data will be treated as random. Then you have reliability. It says, so the analysis on the sample of 10,128 tokens based on the sample size, the reliability of the results is very good. So for this, we can say that we have a good entropy, meaning there's enough randomness, I would say. But if you want to go more into details of each of these, like the character level significance with the counts, transition, character set, the bit level analysis with the different tests, so the FIPS, monobit tests, and so on and so forth. You'll find in the description below a comprehensive article from Portrigger that goes into details of what each of them mean. Now that all of these have been done. Until now, we've seen the proxy module, we've seen the target, how to scope. We also seen repeater, intruder, and in today's video we've seen decoder, comparer, and we've finished with sequencer. We are almost at the end of these videos about Burp Suite. Still one video which will be about extender. So for everything we talked about, the different resources that I've talked about in this video, you can find them in the description box. I hope you enjoyed this video. Thank you for watching, and until next time, bye!